Okay guys, welcome to my YouTube channel. It's your boy SMT, your favorite mathematics and physics tutor. This week we're going to be talking about electric circuits. Okay, let's talk about these electric circuits. Before we even go to that, I first like to apologize to my followers and my YouTube subscribers because I wasn't able to concurrently and consistently post videos on YouTube. So yeah, I'd like to formally apologize for that. I've been busy with my tutoring job, so I didn't have the time to actually make any YouTube content. But I decided to make this video in order to help those that are doing grade 11 and grade 12 so that they can be able to write their June examinations. I hope I'm not too late though. But you can also use this video when you're practicing for your November exams. Okay. Let's get to it. Electric circuits. So whenever you hear the word electric circuits, the first thing that must come to your mind should be current, should be potential difference or voltage, and it should be resistance. So basically that's what should come to your mind whenever you think about electric circuits, because these three powerhouses define what a circuit is. Now, in order for you to understand anything that has to do with circuits, you must first understand potential difference, which is volts, current, which is measured in amperes, and resistance, which is measured in ohms. That's the whole idea of Ohm's law. Now, let's talk about potential difference. Let's talk about the first one, potential difference. Now, what is potential difference? So potential difference is the energy transferred per unit electric charge flowing through it. Oh man, this definition is very chunky, and I'm sure if I would try to say it in your own words, it would be hard for you to understand it. And it's totally understandable because even I didn't understand it when I was in high school. Now, let me help you to derive a definition from the formula, because according to the formula, potential difference is work over charge. Now, what is work? Work is energy measured in joules, and an electric charge is measured in coulombs. Okay, fine. So how would you define then the potential difference? Therefore, potential difference is the amount of energy required to move a single coulomb charge. That's the way you would define potential difference. It is the amount of energy, that is in joules, needed to move a single coulomb charge. Where are you moving this single coulomb charge? You're moving it through a wire. You're moving it through a wire. Yes. So that's what potential difference is. It is the amount of energy needed to move a single coulomb charge through a wire. Please write that down and make sure that you can try to derive that definition from the formula, because you do have a formula sheet in your exam. Don't try to cram definitions. Try to derive them from your formulas. That's the way of a physical science student. Now, let's talk about another thing that has to do with potential difference, EMF, or electromotive force. So electromotive force is the maximum work done per unit charge by the battery or by the source. By the source or by the battery. Now, we said that work is energy. So, in other words, EMF or electromotive force is the maximum energy needed to move a coulomb charge that is provided by a battery. It is the maximum amount of energy needed to move a single coulomb charge by a battery. That's basically what EMF is. It is the maximum work done per unit charge by the source. That's another way to put it. So write down whatever is easy for you to understand. Now we've just debunked what voltage or what potential difference is. Let's go to the second one, electric current. Now, what is electric current? According to the definition that we have here, electric current is the rate of flow of charge. Now, we know that charge is measured in coulombs, and whenever we think about the rate of something, we think about speed, because speed is measured in meters per second. But when you think about charge, that's quantum scale, very small, so we don't think about it in that sense. But in another way, you could say that current is the rate of movement of a charge. It is the rate of flow of a charge, and the rate of flow in this sense is the movement. Therefore, current is the movement of a single coulomb charge per unit time. You can write that down. Charge is the movement or the rate of movement of a coulomb charge per unit time. That's what current is. Now let's talk about the third one, which is resistance. What is resistance? Resistance is the opposition to the flow of electric charges. Now let me help you understand what this means. I'm going to try to draw an electric circuit. Please do not judge my clumsiness because I'm using a freehand sketch here, and it's quite hard to use a laptop when you're drawing something. Okay, good. Now we have to think about it. This is positive and this is negative. So the charge will be flowing from this side to that side. So let's say we have a 4 ohm resistor here, 4 ohm resistor here. We have a 4 ohm resistor here. So this 4 ohm resistor is resisting what is, let's say that we have, let's say 5, let's just say 10 volt battery, yes, for the sake of our calculation, 10 volt battery and a 4 ohm resistor. That's what we have here. That's what we have here. So what would be the current here? So according to Ohm's law, resistance is equal to what? Is equal to V over I. And V is equal to what? Is equal to I over R. So according to Ohm's law, whenever we have a circuit or a wire at constant temperature, the potential difference, which is the energy required to move a charge, is directly proportional to the speed of the charge at constant temperature. According to Ohm's law, it states that voltage or potential difference in a wire at constant temperature is directly proportional to the what? To the current of that wire. Is directly proportional to the current of that wire. Meaning if you increase the voltage or you increase the potential difference, you're basically increasing the energy that is required to move a charge, which will also increase the speed of that charge flowing through that wire. So basically, what a resistor does, it tries to decrease the speed of the charge. That's the point of a resistor. It decreases the speed of the charge. It decreases what? It decreases what? It decreases the current. The current will go down due to the what? Due to the resistor. Because it's decreasing the flow of the charge. It's decreasing the flow of the charge. It's making it flow slower. If you increase the resistance, you're basically decreasing the speed of the charge. But if you increase the potential difference or the energy required to move a charge, you're increasing the speed of the charge, which is the current. So now I've just debunked what current, what potential difference is, and what resistance is. On my second video, I'm going to be doing resistors in series, resistors in parallel, and how they affect current and potential difference. So stay tuned for the next video. I'm going to be posting it consecutively with this one. So I'm going to be posting this one now. Then I'm going to be posting the second video, which is going to be a practical application of what I did with the first video. Ciao, and thank you so much, and please subscribe to the channel and press the like notification, and yeah, that's it.